Hello, a very good afternoon to all. Right. So, I hope my voice is audible to all of you. Please confirm once. So, we start our today's session. My voice is audible to all of you, right? Okay. So, in today class, as in previous class, we are discussed about the syllabus, entire syllabus that how our approach for the upcoming year, right? Which chapter is important, how many chapters are there in NEET and IIT syllabus, right? So, in today class, we are begun with the first chapter, that is the solution and the colligative properties. So, before this, in this chapter, we are covering only the, the important concept of class 11th, right? So basically, if you're talking about the solution and colligative property, so the main thing that you should learn in your 12th class is the concentration defining terms, right? So in today class, we are going to cover all the concentration defining terms so that you grab this concept and you can use this concentration defining terms in your upcoming chapter, that is solution and colligative properties, right? So in today class we are going to discuss about the concentration terms all, right? So let's start with the today session, right? So I'm Vivek Tiwari, and let's start with the today's session, that is some important concept of class 11. So basically there are various concepts in class 11, like in chemical bonding, in solution, concentration defining term. If I'm talking about the thermodynamics, they're having some important concept, but in this particular class, we are going to discuss only concentration defining term. Is it clear to all of you, or anyone having any problem? Right, सबको clear है क्या ये? सबको समझ आया यहाँ तक कि हम क्या करने वाले हैं आज? Right? Okay. So the first thing is what do you mean by this term concentration, right? So if someone asks you what do you mean by this term concentration, so basically what is concentration? So concentration is nothing but we can say that it is the method to find out the concentration of the solution, means that is number of moles of the solute present in either per liter of the solution, per kilogram of the solvent. It means concentration something related to, you have to determine the dilution of the solution, whether it is more concentrated, whether it is a less concentrated, whether it is a more diluted or not, right? So there are various terms to find the concentration. So let's see the first one, that is the percentage concentration. That how will you find the percentage concentration, right? So here we'll talk about the mass percentage, volume percentage, and mass by volume percentage. So all three we're going to talk, right? So what is mass percentage, beta? Can anyone tell me what is mass percentage? Screen पे भी दिख रहा है सबको. What is mass percentage? That is, it is the amount of solute in gram, right? This is important thing. It is the amount of solute in gram dissolved per 100 gram of the solution. It means we know in one important thing is, we know that solute plus solvent, right? One is solute and one is solvent. So solute and solvent is equal to what? Is equal to solution, right? So this is solute and solvent, which is nothing but is equal to solution. For example, if you take 2 gram of sugar and dissolve in a, we say 50 gram of water, right? So what is the solute here? Sugar, that is 2 gram, and 50 gram is solvent, that is water. The total solution becomes 52 gram, right? So here I'm talking about the mass percentage, only mass percentage. It means whenever questions are coming from like mass percentage, always remember that mass of the solution is always 100 gram. Right. If someone say 10% of the solute dissolved in a particular solution, what do you mean by this 10% solution? 10% solution means what? 10% solution means 10 gram of solute out of 100 gram of the solution. Similarly, if someone says, yeah, this is a 50% sugar solution. So what do you mean by this term 50% sugar solution? Means 15 gram of sugar in 100 gram of the solution. So what is the mass of the solvent? That is 85 gram, right? So this is how you can actually find the solute mass, solvent mass, and solution mass. You are going to see example related to this as well. So I hope this is clear. What is mass percentage? It is the amount of solute in gram dissolved per 100 gram of the solution. So this is the important point here, per 100 gram of the solution. Now, if I'm talking about the example, I already mentioned 10% solution of sodium chloride means what? That is 10 gram of sodium chloride present in 100 gram of the solution. Right? I hope this is clear to all of you. What is mass percentage? Right? Yes. Yes, everyone join. Oh, good. So I hope this is clear. Okay, mass percentage. Now, how will you calculate mass percent? What is the formula? It's a very simple formula for finding percentage W by W. What is W by W here, beta? W by W means weight by weight. Weight by weight means what? What is mean by weight by weight? Weight by weight means here the solute is also in gram and solvent is also in gram, right? So both solute and solvent are present in gram. So we can say that this is a weight by weight percentage. So this is the weight of solute in gram, weight of the solution in gram into 100. So we can find this, right? Okay. Now, let's take some example. If someone says, for example, if someone says 10%, right? Someone said 10% weight by weight urea solution. What do you mean by this? Can anyone tell? 10% weight by weight urea solution. What do you mean by this? That is, what is the mass of solute here? What is the mass of solvent here? And what is the mass of solution here? Can anyone tell? 10% weight by weight urea solution. Yes? Anyone? कोई भी बताना चाहेगा क्या? क्या होगा? 10% weight by weight urea solution है. So what is the mass of urea? Or we say what is the mass of the solute, mass of the solvent, and what is the mass of the solution? Can anyone? If you are able to, write in the chat box or able to speak, then please unmute and participate, right? If you are able to do this, then please unmute and participate so that, the class becomes interesting. Yeah, 10 gram of solute, GNB Kutch, 10 gram of solute. सही बोला बेटा तुमने, GNB Kutch. That is 10 gram of solute, right? So 10% weight by weight urea solution means what? That is mass of solute, right? Once again, that is mass of solute. Very good. That is mass of solute is nothing but it is equal to 10 gram. What is the mass of solution or mass of solvent? So mass of solution, we know that whenever the questions are from percentage, जब भी percentage वाला question आएगा 10%, 20%, always mass of the solution is 100 gram. If weight by weight is given, if weight by volume is given 100 ml, volume by volume 100 ml, right? So if the weight by weight is given, then always mass of solution is 100 gram. So this is the 100 gram. So इसमें कोई doubt नहीं है. Now what is the mass of solvent, beta? What is mass of solvent? So mass of solvent is nothing but it is equal to 100 minus 10, that is 90 gram. Very good, right? That is 90 gram. Good. सो ये आ गया हम लोगों का. सो हम लोग इस तरीके से आइडेंटिफाई कर सकते हैं कि व्हाट डू यू मीन बाय 10% यूरिया सॉल्यूशन, राइट? सो इस तरीके से तुम लोग इसको ध्यान में रखो, राइट? इज इट क्लियर टू एवरीवन? नाउ नेक्स्ट पढ़ो. अगर तुमसे किसी ने बोला कि हाउ विल यू फाइंड, राइट, हाउ विल यू फाइंड, दैट इज लेट मी या द सेकंड वन इज, the second one is like mass by volume percentage. What do you mean by this? Mass by volume percentage. Mass by volume. So mass by volume percentage, right? So what is this mass by volume? So we can write as W by V, right? W by V. So we can write this mass by volume percentage as W by V percentage, right? So how will you represent this mass by volume percentage? So basically it is defined as the weight, or we say solute in gram divided by volume of the solution, right? Because this is weight by volume. So this is solute. So solute is taken in gram. So solute in gram, where volume of the solution in volume of solution. So volume of solution in milliliter, right? In milliliter. Multiply by 100. So this is known as mass by volume percentage, right? For example, chalo. For example, if someone says 10% weight by volume, right? If 10% weight by volume, urea solution. What do you mean by this? Anyone? Please start giving answer. 10% weight by volume, urea solution. What do you mean by this? The previous one was 10% weight by weight urea solution. And this one is 10% weight by volume urea solution. So what do you mean by this? Anyone? Yes, yes. Waiting. बताओ बताओ जल्दी. Right? So 10% weight by volume. Yes. किसी का आया? Yeah, that is 10 gram in 1 liter. Beta, we are not talking about 1 liter na. In case of percentage, this is also percentage weight by volume. So जब भी percentage का case रहेगा, always mass of solution, volume of the solution is always 100 only, right? So it's not 1000. We are not talking about molarity and molality, right? Okay, so this is 100 gram, right? So in this 100 gram, why? Because this is the volume of the solution in milliliter, weight by volume, na? So that is 10 gram of the solute. So here, mass of solute, that is mass of solute. So mass of solute is nothing but is equal to 10 gram, right? Where the mass of the solution is equal to 100 ml, right? This is equal to 100 ml, right? So 10 gram of urea is present, or we say in 100 ml of the solution, right? So this is how we can actually calculate. Understand? Here the mass of the solution is 100 ml and the mass of solute is 10 gram. Okay. So this is weight by volume percentage. Now on the similar basis, we have a one weight by weight percentage, one we have a weight by volume percentage. So what is the next? So next we have volume by volume percentage, right? Volume by volume percentage. So what is this volume by volume percentage? Can anyone? Right? Volume by volume percentage means what? That is the volume of the solute. Volume of the solute. Volume of the solute. And this is divided by volume of the solution. That is volume of the solution. So here both solute and solvent are present in milliliter only, right? Because here we are considering V by V percentage, that is volume by volume percentage, multiply by 100, because this is also percentage, hai na? So here mass of the solute is also, for example, if you're considering an example, if it is given 10% volume by volume of urea solution, So what do you mean by this? So it is mean by, what do you mean by this? That is 10 ml of solute present in 100 ml of the solution, right? That is the 10 ml of the solute present in, yes, 10 ml in 100 ml. Very good. JNV Simoga. Yes, good beta. So that is very good. That is 10% of the solute present in 100 ml of the solution. So this is how you can represent. So this is all about the mass percentage, right? So this is all about to determine, to find the concentration using the mass percentage. So this is the way. So we can express percentage concentration as mass percentage, weight by weight, or we say weight by volume, or we say volume by volume. So we have a three-way to represent percentage concentration. Always remember this thing, right? So we have only three ways to represent percentage concentration. The first is mass percentage, that is weight by weight. The second is weight by volume, and the third one is volume by volume. So total we have a three method to represent percentage concentration. I hope this is clear to everyone, right? Chalo. एक क्वेश्चन कर लें और चलो एक क्वेश्चन करते हैं, तुम लोग बताना जरा आंसर इसका क्या होना चाहिए. So it's a very simple question where all of you try, right? If we have a 6% weight by weight urea solution, right? So if we have, right? If we have 6%, just, observe the word, right? 6% weight by weight urea solution, that is urea solution, right? So if we have 6% weight by weight urea solution with the density is given, right? With the density. What is density, beta? So density is equal to 1.060, and that is gram per milliliter, right? Then calculate the strength in gram per liter, right? So you have to calculate the strength, then calculate, right? Then calculate its strength. मतलब concentration ही पूछ रहा है, right? Strength, right? In gram per liter. So you have to calculate the concentration in gram per liter. Can anyone tell me how will you find this? 6% weight by weight. What do you mean by this? 6% weight by weight. It means 6 gram of the solute present in 100 gram of the solution, right? So we have a density for this solution, right? So how will you calculate this? Can anyone tell? Okay, let me explain it to you. We have to calculate the strength in gram per liter. So we have to convert this thing in gram per liter. So we have a density is given already. So density is what? Density is 1.06 gram per milliliter, right? So we know that 6 gram of urea, yeah, someone mass by volume percentage. Okay, so that is, someone says that according to the question, 6 gram of urea, right? This is very much true. 6 gram of urea is present, right? 6 gram of urea is present in how much gram? That is 100 gram of solution. So this is clear to all of you, right? That is 6 gram of urea is present in 100 gram of the solution, right? So 6 gram in 100 gram of the solution. So how will you convert this? Can anyone? We know that what is density? Density is nothing but mass of the solution. Mass of the solution divided by volume of the solution. Volume of the solution, right? So can we calculate this, right? So can we calculate the volume from this equation? Yes, we can calculate. So volume comes out to be, what is the mass of the solution, beta? Total mass of the solution, nothing but 100, right? And what is density? So density comes out to be 1.060. What is the unit here, beta? This is gram. This is gram per milliliter, right? So this is gram cancel. So units comes out to be in milliliter. That is 100 upon 1.0. Explain this. Wait. Yeah, 1.060. So this is the volume in milliliter, right? So this is clear. How will you calculate the volume? So volume comes out to be 100 divided by 1.060. यहाँ तक सबको समझ आया क्या? Please tell fast. How will you calculate the volume of the solution? Right. So this is how will you calculate the volume of the solution. So we know that basically this is for what? So this is volume for the, this comes out to be volume of the solution. Now we know that in 6 gram, right? Let me write here. right? So this ml is equal to 6 gram, right? So for the 1000 ml, you have to calculate for the 1000 ml for, because we have to convert this into, right? We have to convert this into liters. So it comes out to be, that is 1.060 into 1000 into 6, right? So it comes out to be 63.6. So, this is the strength in gram per liter, right? So this is the strength in gram per liter, that is 63.6. So we just have to calculate the gram per liter strength. In chat box, किसने बोला था? Yeah, that is JNV Simoga, right? That is, you have to calculate the weight by gram by volume concentration, right? That is the weight by volume concentration. So this is how we can calculate for this. Okay. So I hope this is clear to you. Right? Okay. Now, the next concentration defining term is very, very important, and this is nothing but molarity, right? So this is a very important topic because we deal with the molarity in the solution chapter as well, right? What is molarity? So what is the exact definition of the molarity, beta, basically? So it is expressed as the number of moles of solute per liter of the solution, right? In simple way, we can say that it is expressed as the number of moles of the solute per liter of the solution, right? So it is in the per liter. Now, percentage wala part khatam. अब यहाँ से क्या शुरू हो रहा है? Per liter of the solution. So it is expressed as the number of moles of the solute per liter of the solution, or we can also express as number of moles of the solute per liter of the solution. So this is how will you actually represent molarity, right? So what is the formula for finding molarity, beta? So this is how we can find molarity. Molarity is nothing but number of moles, right? Molarity is nothing but the number of moles per liter volume. Okay, so this is the formula. Now, we know that we can write mole as, what is mole? Can anyone tell me? Let me explain this here. We know that molarity is equal to nothing but the number of moles in 1 liter of solution, right? In 1 liter of solution. This is all we know. Now, what is the formula for finding number of moles? Can anyone tell? What is the formula for finding number of moles? That is mass upon molecular mass, right? So this is, we can write as mass of solute, that is mass of solute divided by molar mass, right? Mass of the solute divided by molar mass into 1000 divided by volume of solution in milliliter, right? In what? In milliliter. So this is how we can represent molarity. So this is the extended formula for the molarity we use in the equation. या ये फॉर्मूला और ये फॉर्मूला दोनों सेम है बेटा, बस फर्क क्या है? जस्ट नंबर ऑफ मोल को हमने यहाँ लिख दिया है. नंबर ऑफ मोल इज नथिंग बट इज इक्वल टू मास ऑफ सॉल्यूट अपॉन मोलर मास, एंड here the volume is in liter only, because in questions generally the volume are given in milliliters, so you have to convert this into liter. So do this, we divided this term by 1000, right? So this is the volume, the solution in milliliter divided by 1000. So this is the complete formula for finding the molarity, where n represent the number of moles of the solute, and capital M represent the molecular mass, and V represent the volume of the solution. Always remember volume of the solution, not volume of anything. Always remember volume of the solution you have to take in milliliter and just divided by 1000, right? So this is how you can find molarity. समझ आया सबको? जल्दी बताओ, molarity clear है क्या सबको? What is molarity? Tell me fast. Clear है सबको? What is molarity? Any doubt related to this molarity? No? Chalo. So this is the formula for finding molarity. Now, let us assume if V1 ml of C1 molarity solution is mixed with the V2 ml of C2 molarity solution, same substance or solute, then we can also write as, right? So how will you write as, beta? So we can express this. We take one. No. Just give me a minute. Right. So let's see if the two solution having volume, for example, let us consider a solution number one, right? So this is the solution number one, and solution A, let's say, and this is solution B, right? So this is nothing but solution B. So we can write as solution B. So they having volume V1 and the molarity of the solution is M1. Similar, this solution having volume V2 and molarity of the solution M2. So if we mix these two solution, right? If you mix these two solution, that is solution A plus B. So this is combinedly solution A plus B. So you have to find what is the molarity of the solution, right? So what is the molarity of this solution, right? So if you mix the two liquid having volume V1 and molarity M1, having volume V2 and molarity M2, and you want to find the molarity of the mixing after mixing, right? So what is the molarity for this, right? So let's find out. So that's what we can write here, that this is nothing but is equal to this one, right? So we can write as that is M1 V1 plus M2 V2 is nothing but is equal to M3, and here volume is equal to V1 plus V2. वॉल्यूम ऐड ही तो हुआ, अगर यहाँ 2 लीटर यहाँ 3 लीटर था तो टोटल 5 लीटर हो गया, राइट? सो दिस इज 2 + 3 5 लीटर, so volume will be added. So this is the final molarity, right? So what is the final molarity? So this final molarity M3 comes out to be, it is nothing but this is equal to M1 V1 plus M2 V2 and divided by the total volume, that is V1 plus V2. So this is the formula for finding the molarity of the unknown solution, right? When you mix two solution of the same having same substance or solute, then we use this formula, right? Sometimes molarity can also be represented as capital C. So both are same, right? So we can represent molarity as molarity. We can represent molarity. Sometimes they can also represent it as either M or C. So both are same, right? Both are same. So always remember this, because molarity is nothing but way of expressing concentration, right? So this sometimes they also written as C. So we can also write the formula as C3 is equal to nothing but C1 V1 plus C2 V2 divided by V1 plus V2, right? So I hope this is clear to you. How will you find the resultant molarity? Yes? Anyone having any doubt till? No? आगे बढ़े? Yeah. Now, the next one is molality. What do you mean by this term molality? So basically, molality is nothing but it is defined as the number of moles of solute per 1000 gram, or we say 1 kilogram of the solute, right? So there is a big difference between molarity and molality. In molarity, we can define molarity as the number of moles of the solute present per liter of the solution. So in molarity, we are considering per liter of the solution. But in molality, we are taking solvent mass, that is per 1000 gram, or we say 1 kilogram of the solvent. That is the number of moles of the solute present per kilogram of the solvent, right? So this is how will you find the molality of the solution, right? Now, we can use the formula for the molality just like the molarity. So we can write molality. Molality is represented by small m. Always remember this thing. Molality is always represented by small m, where the molarity is represented by capital M, right? So what is the formula for finding molality? So it is very much similar, just like number of moles per liter. Instead of per liter here, per kilogram of the solvent is there, not solution. Always remember per kilogram solvent. So let me write the formula again. So number of mole, we can express number of mole as mass of the solute, right, divided by molar mass, right, divided by molar mass. So this is mass of the solute divided by molar mass into, that is nothing but 1000, and upon what? Mass of the solvent or mass of the solution or volume? What? Tell me first. Mass of the solvent, mass of the solution or the volume? क्या आएगा नीचे? Yes, that is mass of the solvent, right? So this is the mass of the solvent in gram, right? For a gram only we divide with 1000 to become kilogram, right? So this is the formula for finding molarity of the solution, right? So this is how we do find the molality, sorry, right? So one important note about molality is, first, it depends upon the mass of the solvent. The second, it is represented by small m. And the third and the most important thing is molality not depends on temperature, right? So molality not depends on temperature, and therefore in solution or colligative properties, if we're talking about the colligative properties, elevation in boiling point, depression, freezing point, we always consider molality, not molarity. Can anyone think why this is happening? Why we won't consider molarity instead of molality? Why in all colligative property maximum we are using only molality instead of molarity? Why? Yes, because molality is temperature independent. It does not depend upon the temperature. But in case of colligative properties like elevation in boiling point, depression in freezing point, we deal with the temperature, right? So we want such concentration defining terms which does not affect with the temperature. Otherwise, our calculation become, disturbed. So that we use only molality, not molarity in solution of colligative property, right? Because they all are temperature dependent thing, and molality does not change with the temperature. I hope this is clear to you. सबको समझ आ गया what is molality? And the three important note about the molality. The first one is it depends upon the mass of the solvent. The second is it is represented by small m, and the third is molality is not dependent on temperature. It is independent of temperature, right? So let's see some numerical related to this molarity and molality, so that our concept becomes strong and we can able to solve numerical related to such topic, right? So in the first question, what they ask actually. So in example number 1, they are saying if 20 ml of 0.5 molarity Na2SO4. First of all, what do you mean by this term 0.5 m? Can anyone tell? Just like in case of percentage, if 10% are given, we can say that 10 gram in 100 gram of the solution. So what do you mean by 0.5? So similar 0.5 means what better? That is 0.5 moles of sodium sulfate, that is Na2SO4, right? That is 0.5 moles of Na2SO4 is present in 1 liter, or we say 1000 ml of solution. So this is the meaning of this term, right? So always remember this meaning, right? So if someone asks what is 0.5 m, means 0.5 moles of Na2SO4 present in 1000 ml of the solution. Instead of 0.5, it is written as 2m. What do you mean by this term 2m? 2m is nothing but the 2 moles of sodium sulfate is present in 1 liter, or we say 1000 ml of the solution. So this is very much clear, right? This thing you need to remember, right? So if 20 ml of 0.5 molar Na2SO4 is mixed with 50 ml of 0.2 molar H2SO4 and 30 ml of 0.4 molar Al2 ammonium sulfate solution, calculate the concentration of Na plus ion, H plus ion, SO4 twice ion, and Al3 ion, assuming 100% dissociation. That is, they are completely dissociated, right? So assume this is completely dissociated, right? Now, how will you find the concentration of this? So we know that for finding the concentration, let's assume if I'm finding the concentration of sodium plus, right? This square bracket always represent concentration beta, right? This square concentration is always represented in this square bracket. So square bracket is always represented as concentration. Now, for example, if you want to find concentration of sodium, what we need? Basically, what we need for finding the concentration, that is the number of moles, right? That is the number of moles of the solute upon volume, right? This is what we need. That is the number of moles of the solute divided by the total volume. This is what, let me write here. That is concentration is nothing but number of moles divided by volume of the solution. Volume of solution. This is how will you find the concentration beta? This is the way only, na? Yeah. So first, let's find the number of moles and find the volume of the solution. So we can observe that here, what is the volume of the solution? So volume of the solution. So volume of solution in the given question is nothing but is equal to 20 ml, 50 ml, and 30 ml. So this is 20 plus 50 and plus 30. So it comes out to be 100 ml, right? So this is the total volume of the solution, right? Now, if we want to find out the concentration of Na2SO4, so how will you find the concentration of Na2SO4 beta? We know that Na2SO4, the question says that they 100% dissociate. So when they dissociate, they convert into 2 Na plus, right? And SO4 twice negative. So here the concentration, number of moles of Na is what? That is 2 mole of Na, right? 2 mole of Na. So we know that 0.5 mole of Na2SO4, right? 0.5 molarity Na2SO4 is mixed. So what do you mean 0.5 mole of Na2SO4 present in 100,000 ml of the solution? Now in this question, it is given that 10, right? That is the 2 mole of Na and 1 mole of SO4 is produced. So how can you write this? What is the total number of moles for this? Can anyone say? Right? Na2SO4, total number of moles of Na2SO4. Can anyone? Yes? No? Right. So how we can calculate beta? That is nothing but the concentration of Na plus is equal to number of moles of Na. So number of moles of Na is what? Okay. You can also calculate by using a or we can say a formula like just a normal calculative method. We know that 0.5 mole of Na2SO4, right? Mole of Na2SO4. Na2SO4 contain how much? That is 2 mole of sodium, right? So 2 mole of Na plus and the 1 mole of sulfate. So we can calculate by like this is nothing but the 20 mole divided by 100. So it comes out to be what? 20 divided by 100. This is 0.25, right? We can say that 0.2 molarity. So this is the concentration, like 0.2 molarity. Okay. So this is how will you get the concentration of Na plus ion. On the similar basis, if you want to calculate the concentration of H plus ion, what you have to do? H plus ion, what you have to do for calculating the concentration of this? Yes. Can anyone tell me? Okay. How many of you find difficulty in finding this 20? Can anyone tell me? किसी को भी समझ नहीं आया हो ये 20 कैसे आया? So that I can tell you another method for finding this value. Let me tell. If you want to actually find the molarity, na, so what you have to do, molarity is nothing but moles upon volume, right? We all know that this is nothing but moles upon volume. So we know that molarity is equal to number of moles upon volume, right? Now you want to find the number of moles. So number of moles is what? So number of moles is nothing but molarity into volume, right? So what is the molarity of Na2SO4 beta? That is 0.5. What is the volume? Volume is nothing but 20 ml, right? So we can calculate now. This is 1 by 2 into 20. So what is this? This is comes out to be 10, right? So number of moles is 10, right? So number of moles is 10. But now here we can say that 2 mole of Na is present in Na2SO4. That's why I write as 20. समझ आया सबको? That's why हमने इसको क्या लिखा है? 20 लिखा है. क्लियर है सबको? हमें यहाँ क्या चाहिए था? नंबर ऑफ मोल्स. What we need? Number of moles divided by volume of the solution. So for the number of moles, we use this formula, molarity. So molarity is equal to number of moles upon volume. So from this formula, we calculate number of moles is equal to molarity into volume. Molarity of the solution is given, volume is already given. So we can calculate, it comes out to be 10. So 10 mole of sodium is present in this 0.5 molar solution. But as we can see that in Na2SO4, Na having 2 moles of Na is produced. So we can multiply 10 by 2, that comes out to be 20. समझ आया? On the similar basis, how will you calculate the concentration of H plus? Tell me first. How will you calculate the concentration of H plus? Yes, concentration of H plus. Again, same formula. For calculating the concentration of H plus, what we need? We need number of moles of H plus divided by volume of the solution. Volume of solution, right? Number of moles of H plus divided by volume of the solution, right? So what is the number of moles of H plus? Can anyone tell me? Number of moles of H plus. So let's see the question. So 0.2 mole of H2SO4 and 50 ml is given, right? So we know that H2SO4. How H2SO4 dissociate, beta? H2SO4 dissociate as 2H plus and SO4 twice negative. So this is how they dissociate. Now, again, molarity is equal to number of moles. Same formula. Number of moles divided by volume, right? Volume. So if you want to calculate the number of moles comes out to be molarity into volume. So what is the molarity? Molarity is nothing but 0.2 and volume is 50 ml, right? So that is 0.2 into 50. This comes out to be 2 into 50 upon 10. So it comes out to be 10. So number of mole is 10. Again in H2SO4, it will give 2 mole of H plus. So we can write as 20 again. So this is again 20 upon divided by what? 20 upon my total volume, 100 again. So this comes out to be 0.2. जल्दी बताओ सबको समझ आया? Everyone? Is it clear to everyone? Yes or no? Tell me fast. Tell me fast, beta. Anyone having any kind of doubt till in this question, please ask. So I'm giving you homework. You have to calculate the concentration of SO4. SO4 twice negative and the concentration of Al plus 3. So you all have to calculate the concentration of SO4 plus ion and Al plus 3 ion, right? I already calculate the two concentration, that is H plus and Na plus. You have to calculate other two concentration, that is SO4 twice negative and Al plus 3. Can we move to the next question? Tell me fast, yes or no? Can we move? Right? Okay. So the next one is derive the relationship between molality and molarity of the solution, right? So you have to, derive the relationship between molality and molarity of the solution, in which W gram of solute of molar mass M gram per mole is dissolved in W gram of solvent having density. Result solution is equal to, density of the resulting solution is equal to T, right? So you have to derive the relationship between the molality and molarity by using density, right? So by using the concept of density, you have to derive the formula for this, right? So let's see how will you derive the formula. We know that simply we can say that whenever someone asks, let us assume if the density is given. Now, if someone asks, you have to calculate the molality of the solution, right? Simple. Molality, right? Someone asks, you have to calculate the molality. So for calculating molality, what you need? You need mass of the solute. You need mass of the solute divided by molar mass into 1000 divided by mass of solvent, right? So molality, for molality, what you need? Mass of the solute upon molecular mass into 1000 upon mass of the solvent. Now, I give one condition here in this question, mass of the solvent is not provided. Instead of this, volume is provided, right? So mass of solvent is not provided. Instead of this, volume is provided. Or in case of molality, instead of volume, mass of the solution is provided. Then how will you calculate this? So we know that, but in all such type of question, density is always given. So we know that density is equal to what? So always remember, density is equal to nothing but mass of the solution. Density is equal to mass of the solution upon volume of the solution. Volume of the solution. So density is nothing but is equal to mass of the solution divided by volume of the solution. So this is all about the density, right? Mass upon volume. Now, we have to calculate the mass of the solvent. So how will you proceed? So for the mass of the solvent, first of all, we need to calculate mass of the solution from this formula. So we can calculate mass of the solution, right? So mass of the solution is nothing but density into volume. So we can calculate mass of the solution. Once we calculate mass of solution, we know that. What we know? We know that is, once we calculate mass of the solution, what we know? We know that is solute mass, right? That is, wait, that is solute plus solvent is equal to solution mass. So we know the solute mass because this is always given, because 20 gram, 30 gram, they are always given. So by knowing this value, we can calculate this value because we know the mass of solution as well. So we can calculate mass of the solvent. So this is the need of density actually, right? So this is the need of density. So whenever the mass of solvent is not given, density is given. So we can, you just follow this step to find out the mass of the solvent. On the similar basis, let us assume if you have to calculate molarity, right? If you have to calculate molarity. So what is molarity? This is nothing but mass of solute divided by molar mass into 1000 divided by volume of the solution. Volume of solution. And now assume that volume is not given in this question. Instead of volume, density is given. Then how will you approach? We know that density is equal to mass upon solution of volume. So we can calculate volume of the solution is equal to mass of the solution upon density. So we can calculate this volume by using nothing but mass of the solution divided by density of solution, right? So this is how we calculate volume of the solution and mass of the solvent using the concept of density. So in any question, when volume or mass of solvent is not given and you want to calculate molarity and molality of the solution, you need to use this concept of density, right? So I hope this is clear to everyone. Clear, sabko? Right? Okay. Done. Good. Now, so we have one important relation as well. So this is the best way. So use the formula density and just put the values. You can calculate this. One another shortcut trick for this, to just put the values and get the value for the molality. So this is the relationship between molality and molarity, we can say. So this is the relationship between molarity and molality, right? So direct formula is there. So what is the relationship between molality and molarity by using the direct formula? So we can calculate molality. Molality is always represented by small m. So molality m is nothing but is equal to molarity, right? Molarity into 1000, molarity into 1000, right? And this is nothing but 1000 D minus molarity into molecular weight, right? So this is also, we can calculate this by using this standard formula as well. So if you want to calculate by using this formula, or you can use this relation, it's up to you. I always suggest to use this relation because this is simple and easy to understand. So you can calculate by using this only, right? Now, let's see, solve the question B on the basis of this same theory. That in this, you have to calculate the molality of 1.2 molar H2SO4 solution. If the density is this, right? So you have to calculate the molality of 1.2 molar H2SO4. 1.2 molar. Let me write the data here. 1.2 molar H2SO4, right? 1.2 molar H2SO4 and density is 1.4 gram per liter. And density is given 1.4 gram per milliliter, right? This is all, right? And you have to calculate the molality, right? You have to calculate the molality. Let's calculate. What is molality, beta? Molality is nothing but, we can represent molality as small m. Molality. So molality small m is equal to number of moles, that is mass of the solute divided by molar mass into 1000 divided by volume of, molality you need to calculate. So sorry. Just erase this. Okay. Okay. And this is mass of the solvent. Mass of solvent. Okay. Now, how will you calculate this? We know that mass of the solute upon molar mass is nothing but number of moles. I already told you in the beginning of the class, what do you mean by this term? 1.2 m. Yeah, 0.5 m. This means what? That is 1.2 moles. 1.2 moles of H2SO4. H2SO4 in what? In 1000 ml of solution. So this is already I told you in the beginning of the class by the definition of molarity. We can say that 1.2 m means what? 1.2 moles of H2SO4 in 1000 ml of the solution. Right. So we know that the total number of mole is nothing but 1.2 mole. So we can write as, right, this comes out to be 1.2. Directly we can write because this is nothing but this is equal to mole. So this is equal to 1.2 mole. This is 1000. Now, how will you calculate the mass of the solvent? Right. We know density is equal to mass of the solvent upon volume of the solvent solution. Mass of the solution upon volume of the solution. Now you want to calculate the mass of the solution. So what is this? Density into volume. What is density? Density in this question is 1.4. What is volume? That is 1000. So it comes out to be, yes, that is 1400. So that is 1400 gram. So this is the total mass of the solution. Now what is the mass of the solute? Can anyone tell? Mass of the solute. We know number of mole is equal to mass upon molar mass. So from this we can calculate the mass, which is equal to number of mole into molar mass. What is number of mole here? That is 1.2. What is molecular mass of H2SO4? We all know 98. Right. So just calculate 98. How will you calculate, beta? Fast. That is 1.2 into 98. It comes out to be 117.6. Right. It comes out to be 117.6. So this is the molar mass. So now we get the mass of the solute. We get the mass of the solute. So we have a solute mass plus solvent plus solution. Right. So we get the solute mass. That is 117. Now what is solvent mass? Solvent mass, we get the solution mass 1400. So we get the solvent mass easily. Easy or not? Tell me fast. समझ आया सबको? That is 1400 minus 117.6. It comes out to be 1282.4. Right? It comes out to be 1282.4 gram. The question is done. It's equal to 1282.4 gram. Just solve this, right? So just solve this 1.2 into 1000 divided by 1282.4. So it comes out to be 0.9, right? 0.935. So this is the molality of the solution. समझ आया सबको? Tell me fast, everyone. Got it or not? Tell me fast, beta. This is the last question for this class. Tell me fast. सबको समझ आया? Otherwise, we can once again try to understand, right? Yeah. GNV Simova, good. Rest all. सबको समझ आया? So this is how we can actually solve the question of molarity and molality by using the concept of density, right? So let's meet in the next class from the Monday, right? So that is tomorrow only. So from tomorrow only, we are going to start the syllabus, right? This is the basic terms. So from this only, we start our new next, right? So thank you guys. Meet in the next class. Till just revise this thing and try to learn the formula for concentration defining terms like mass, percentage, molality, and molarity. And one mole fraction. We also cover this topic in the upcoming classes, right? So this is all about the concentration terms and some important topics of this 11th class, right? So thank you.